morning everyone. Today we are going to discuss the next topic in digital electronics, and which is fundamentals of Boolean algebra, laws of Boolean algebra, logic gates and universal gates. In the last presentation, in the last lecture, we started number system, digital systems. What are digital systems? Difference between analog systems and digital systems, and number system. So let's recall first. In a first presentation, we first talked about the digital systems. What is digital system? Digital systems is basically a system which are working on the zeros and ones, like binary numbers. So there are also analog systems. So what is the difference between an analog system and a digital system? In a digital system works in a discrete form. That means at only at some time, at only some instant of time, the output is coming. But in analog system, the waves are sine waves and cosine waves. So at every instant of time we get the output. So a digital system is in some form digital system is better, in another form some of them like analog systems are okay. So there are some advantages of digital systems over analog system and some are disadvantages. So next topic we discussed was number system. There are decimal number systems, binary, hexadecimal, octal. We already discussed. Now today's topics is Boolean algebra. So Boolean algebra is a logical algebra in which symbols are used to represent the logical levels. So in this Boolean algebra we are using zeros and ones, and these logical algebra are basically used in electronic circuits and signal. A logic 1 will represent the closed switch and 0 will represent the open switch, or we can say that 1 represents on condition and 0 represents the off condition. So closed switch, when 1 represents closed switch means the circuit is complete. That means the current is or the voltage is applied in the circuit and it will flow. When the logic is 0, that means it will represent the open switch. That means low voltage and the circuit is open. That means there is no flow in the current, because there is when the switch is open, that means no flow of the current. So in a logical addition, what is addition? Addition means any 2-bit is going to be added and makes a new form. So in a logical addition, there are two types of additions. One is logical and one is arithmetic. In arithmetic, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 1 plus 0 is 1, but 1 plus 1 is 2 in arithmetic. But in logical, 0 plus 0 is 0. That means both the conditions are off. 0, 0, both the conditions are off. When both the conditions are off, there is no current in the circuit. That means the condition is 0. Next, 0 plus 1. 0 plus 1. One condition is 0. One condition is 0. That means one circuit is switched off and the one is open switch. One is open switch, one is closed switch. So in a closed switch, the current is going to be flow. So because of this closed switch, the output should be 1. Similarly, 1 plus 0, 1 in this one is closed switch, so output will be 1. In 1 plus 1, both the inputs are closed switch. When both the inputs are high, the output should be high. So that means 1 plus 1, the high output is 1, the low output is 0. In this digital systems, we only talked about zeros and ones, only talked about the binary forms. Now next is a logical addition. The table represents a standard binary addition except for the last entry when both x and y are positive. The value of x and y is 1. The symbol represents the positive, but it is a logical addition, and logical additions tells you that when 1 plus 1 means both the inputs are high. When both the inputs are high, the output should be high. Now, what is logical multiplication? There are two types of multiplication. Similarly, as we talked about addition, two types of multiplication. One is arithmetic multiplication, second is logical multiplication. So when logical multiplications occurs, that means 0 into 0. 0.1 is 0, because anything which is going to be multiplied with 0 is equal to 0, and 1.0, anything which is multiplied by 0 is 0, and 1.1 is equal to 1. In a logical as well as in arithmetic multiplication, 1 into 1 is equal to 1. So Three of the basic laws of Boolean algebra are the same as in the ordinary algebra: the commutative law, the associative law, and the destructive law. So in a commutative law, we can say that for addition and multiplication of two variables, that means a plus b is equals to b plus a. Let's take an example. A is 1, b is 0. 1 plus 0 is equal to 1, and b is 0 plus 1. So 1 is equal to 1. That means LHS equals to RHS. Or in multiplication, we can say that A is 1, B is 0. That 1 dot 0 is equal to 0. Similarly, B is 0, A is 1. 0 dot 1 is 0. So 0 is equal to 0. That means in a commutative law, we can prove that LHS is equal to RHS. In an addition form, A plus B is equal to B plus A. In a multiplication form, A dot B is equals to B dot A. So the second is associative law. Associative law is told you that A plus B in a whole bracket plus C is equal to A plus in a brackets B plus C. So if we can say that A plus B is 0 plus 1. 0 plus 1 is 1 plus 1. A is 0, B is 1, C is 1. Then 0 plus 1 is 1, 1 plus 1, 1. So 1 LHS should be 1. Now A is 0. 0 plus 1 plus 1, 1. So 0 plus 1, 1. Then LHS is equal to RHS. So we can prove that in a multiplication form also. Now the destructive law is told you that A brackets B plus C is equals to AB plus AC. So there are the three laws which we are going to use to solve the Boolean functions, or we can say that Boolean algebra, that commutative law, associative law, destructive law. Commutative law, just recall it, A plus B is equals to B plus A, and A dot B is equals to B dot A. Associative law, A plus B whole bracket plus C is equals to A plus brackets B plus C. In destructive law, A bracket B plus C is equals to AB plus AC. So these are the basic some of the basic identities of Boolean algebra are x dot 0 is equals to 0. X is anything, any number. 0, x is 0 or 1. If 0 dot 0 is also 0 and 1 dot 0 is also 0. So anything, you can take anything. X is 0, x is 1, dot 0 is equals to 0. Similarly, x plus 1 is 1. X is any number, 0 or 1. If x is 1, that 1 plus 1 is 1. And 0, if x is 0, that 0 plus 1 is also 1. So both the identities we can say that. Now x dot 1 is equals to 1. We can take x, any, 0, if 0 dot 1 is 1, 1 dot 1 is 1. Now next is x plus x is equals to x. If we take x is equals to 0, then LHS should be equal to RHS. Then 0 plus 0 is equal to 0. So LHS is equal to RHS. Now take x is equals to 1. Then 1 plus 1 is equals to 1 plus 1 is 1, LHS is 1, now RHS is also 1, then LHS is equals to RHS. Now these are the some basic identities of Boolean algebra, that x dot x is equals to x. Let's take x is 0, so 0 dot 0 is equals to 0, and x plus x bar is equals to x. X bar is not gate. That means 0 is converted into 1 and 1 is inverted into 0. So let's take x is equals to 1, then 1 plus 0 is equal to 1, then 1, because this is 1, this is 0, because 1 x is inverted into 0, x bar is 0 and this is 1. So 1 plus 0 is equals to 1 is equals to 1. So this identity is going to be okay. Now x dot x bar is equal to 0. X is 0. Now this x bar becomes 1. 0 dot 1 is equal to 0. Similarly, x plus y is equals to y plus x. Xy is equal to yx. X plus y plus z is equals to x plus y brackets plus z. These are the basic identities you can look at, and take x any number 0, 1, y any number 0, 1. Now the next topic from which the basic digital system is going to be start, or we can say that to perform any functions or to perform any circuit, to present any circuit, we need these logic gates. These logic gates are basically used to multiplication factor, for addition factor, or we can say that they are known as AND gate, OR gate, NOT gate. A logic gate is defined as an electronic circuit with two or more input signals and only one output signal. These circuits are OR gate, AND gate, inverters, NOT gate. Now there are two more gates known as universal gates. Universal gates are nothing but these are the gates which is known as AND gate, NOR gate, and they are the gates we can make any gate. Like with the help of NAND gate we can make AND gate, OR gate, NOT gate. With the help of NOR gate we can make AND gate, NOT gate and OR gate. So NAND and NOR are the basic gates. By using these two gates we can make any of the logic gates. So OR gate, AND gate, first of all we talked about OR gate, AND gate, NOT gate. So what is OR gate? OR gate is, you can see that this is the OR gate circuit diagram. In this X and Y, Z, this is Z, X or Y are the inputs and Z is the output. So Z is equals to X plus Y. In the inputs, if we take X plus Y, if we take X is 0 and Y is 0, then the output should be 0. If X is 0, Y is 1, then the output is 1. If X is 1, Y is 0, that Z is 1. If X is 1, Y is 1, then Z is 1. So in this 0, 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So we can conclude the OR gate, if any of the input is high, that means the output should be high. If any of the input, that means in both the, if X is 0 and Y is 0, no input is high, that means the output is 0, low. If X is 0 and Y is 1, that means Y input is high, so output should be high. If X is 1 and Y is 0, that means X input is high, that means output is 1. If X is 1, Y is 1, that means both the inputs are high, that means output is also high. So you can see that an OR gate is a logic gate with two or more input and only one output. The output signal will be high, that means it will be 1, or in a closed switch if and only if when any of the input signal is high or logic 1. OR gate performs logical addition. So next is AND gate. What is AND gate? AND gate is, you can see that this is X, Y, both are inputs. Z is equals to X dot Y. In X dot Y is equal to Z. When X is 0, Y is 0, Z is output is 0. X dot Y is 0. 0, X is 0, Y is 1. That means Z is 0 dot 1, 0. When X is 1, Y is 0. That means Z is equals to 0. And X is 1, Y is 1, Z is equals to 1. So 0 dot 0 is equal to 0. 0 dot 1 is equal to 0. 1 dot 0 is equal to 0 and 1 dot 1 is equal to 1. So from this truth table we can conclude that the AND gate, when the input, when both the inputs of a AND gate is high, then only the output should be high, because you can see that when both the inputs are low, the output should be low. When one of the input is high and one of the input is low, the output is low. When one of the input is high and one of the input is low, the output is low. And when both the inputs are high, the output is high. So we can conclude that when both the inputs are high, the AND gate gives you the high output. So AND gate is a logic operation, logic circuit with two or more inputs and only having one output. The output signal of an AND gate is high only if all input signals are high. An AND gate performs logic multiplication on inputs. So inverters and NOT gate. An inverter is a gate with only one input signal and one output signal. The output signal is always the opposite or complement of the input signal. It is only, the inverter is only having one input and that one input is converted into one output. That means if X is an input, the output is X bar. If A is an input, the output is A bar. Bar means the complement, the inverter. If X is 0, the output should be 1. If x is 1, the output should be 0. An inverter is also called a NOT gate because the output is not the same as the input. So this is the inverter, A bar, NOT gate. If A is 0, then the output should be 1. If A is 1, the output should be 0. So what is universal gates? Universal gates are, there are two type of universal gates, NAND gate and NOR gate. These gates are the most popular and most widely used gates because with the help of these two gates we can perform, or we can consider, or we can construct the logic gates like AND gate, NOR gate, OR gate and NOT gate. Since any logic circuit can be constructed using only NAND or NOR gate. So these are the there are only two universal gates, NAND gate and NOR gate. So first we are discuss about the NAND gate. What is NAND gate? NAND gate is a NOT gate and a AND gate followed by NOT gate. The output is an AND gate followed by the NOT gate. That means the AND gate, the output of the AND gate is going into the inverter and then converted into the NAND gate. So so the NAND gate has two or more inputs but only one input signal. So you can see that in this NAND gate, C A B C is equals to A dot B bar. So A or B. Okay, thus then the AND gate. First of all, we can discuss AND gate. 0.0 0, 0.1 1, 1.0 1, 1.1 1. So after this, we can, this AND gate is followed by NOT gate. So the output of the AND gate then invert into the NAND gate. So 0 0 0 converted into NOT gate, going through the NOT gate becomes 1. Okay, now 0.1 becomes 0, going into the NOT gate becomes 1, 1.0 is equal to 0, going into the NOT gate becomes 1, and 1.1 is equal to 1, and going into the NOT gate becomes 0. So this is the output of the NAND gate. So we can conclude from the this truth table, the NAND gate is a logic circuit in which having two inputs and only one output, and the input is high. The input is high when we can say that the input is low when both the inputs when the output is low when both the inputs are high. So both the inputs, that means A is 1, B is 1. That means when both the inputs are high, the output is low, otherwise the output should be high. This is the conclusion of NAND gate. That means having two inputs and one output, and the output should be low when both the inputs are high. So next is NOR gate. What is NOR gate? NOR gate is a OR gate followed by NOT gate. So in this we can going through the circuit is going through the OR gate and then NOT gate, and we now after NOT gate we get our results. So in this we can say that A and B are the inputs and A plus B bar is the output. So 0.0 for OR gate, only for OR gate, 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 1. After this OR gate, NOT gate operation is going to be performed. That means 0 plus 0 is equal to 0. In the NOT gate it will become 1. 0 plus 1 is equals to 1. Going through the NOT gate it will become 0. 1 plus 0 is equals to 1. Going through the NOT gate it will become 0, and 1 plus 1 is equal to 1. Going through the NOT gate it will become 0. So we can conclude in this NOR gate, we can conclude that having two inputs and one output, and the output is high when both the inputs are low. When both the inputs are low, that means A is equal to 0 and B is equal to 0, only then the output is high, otherwise the output should be low. In the last we can say that in the next topic, or we can say that in the next lecture, we are going to discuss about the exclusive gates, XOR gates, and after that we are going to discuss about the minimization techniques of the logic gates and the sequential circuits and the combinational circuits. So in today's topic, we are concluding that we are concluding the Boolean algebra, the Boolean functions, the logic gates and the universal gates. Thank you.